All right. So what we're going to do today is I'm gonna kind of walk you through how Docker works and how to use it. So there's, I guess one caveat or yeah, one caveat warning I would give is don't worry about trying to like understand what Docker is. Just worry about how to use it, and using it is pretty simple. So yeah, you can go through and look at this if you want, but I'm just going to run through a couple of examples. So the basic example we're going to use today is I want to have a description of a program that runs in Python 2. So during install fest, we all installed Python 3 on the computers, and it's possible, depending on what version of Mac, I'm not sure if Python 2 might not even be installed on your computer. It used to be installed by default. Since it's deprecated now, I'm not sure that is the case. But so Python 2, let's just say that I want to run a program in Python 2 on my computer. So if I wanted to do that, without Docker, I would just install Python 2 and make sure I was running Python 2, and then write the program and run it. And then if I wanted to run that program somewhere else, I would also have to make sure, hey, you have to have Python 2 installed if you want to run this. So it creates this issue. And if you want to run this program on lots of different machines, then you have to not just specify your program, you also have to say, and you have to have Python 2 installed. So you can eliminate that headache by just pre-installing Python 2 on something that people can run. So what I'm going to do is I'm going to open up VS Code. Let's see. And I'm going to walk through all the nitty gritty here. But the first thing that you need to do is to create something called a Docker file. And it's a capital D Docker file with no extension. So it's a little odd, but this is what you do. So Docker file with a capital D and no extension. Then I'm gonna paste this and I'll describe what these things are doing. And then I also have this program, so I'm gonna grab this, which I believe is here. Okay, so I have this program written in Python 2. So this is what basically we've been doing so far. We as software developers writing code. So here it is here, and VS Code doesn't like that, but that's fine. We can ignore that. Now here is the infrastructure or the ops part of what we want to do. So we want to have this code, and we want it to run in Python 2. So the way this works is the first line of a Docker file is always going to be from blah, blah, blah. And this blah, blah, blah is another base image of some kind. It's usually an operating system. So it could be, Ubuntu Linux or, whatever. It's basically going to be some flavor of Linux. So there are basic images, and then there's also kind of pre-installed images with useful things pre-installed. For example, Python. I want an image with an operating system. I don't really care what the operating system is, but I want it to have Python 2 installed on. So this exists. And we know that this exists because we're going to go to Docker Hub. And Docker Hub is basically like GitHub. It's GitHub, but instead of, this is my account. Let me see if I can not go to my account. So here's what you'll see if you're not logged in, basically. So if you go to Docker Hub, there's just a ton of images available. And here's one, Alpine. So this is a flavor of Linux. Nginx, this is a web server, which we'll use later. BusyBox is kind of like a bunch of different utilities, and Ubuntu you may have heard of. This is another Linux distribution. And here's a Python. So if you know that your program requires Python, then what you should do is look in Docker Hub for an official image. So pretty much everything you do should be using an official image. You can see that right here. So this just means that, you know, this is well maintained and you can basically rely on this. So I'm going to click here, and then you can see there's just a whole bunch of stuff that you can use. Supported architectures, blah, blah, blah. So there's just a ton of variations. Like I want Python, but I want Python 3.9. And I want Python 3.9 on, you know, where are we? Oh, Python 3.9.17 on Bullseye or Alpine, or and there's also a whole bunch of others. So for the most part, you don't really need to worry about like what all these different variations are. 90% of the time, it doesn't matter. But that's kind of the process that you go to. And let's say I want, I don't know, we're not going to use anything like this, but let's say, okay, so Django actually has, it used to have, apparently, an official image. So this would be an operating system that's got Django pre-installed on it. Notice that this is deprecated, but you can see what this looks like. Blah, blah, blah. So it's deprecated in favor of the standard Python image. So why might the Django image have been deprecated in favor of the standard Python image? You can speculate. I don't know the real answer, but
Politics. No, I don't know.
Could be, yes.
I was actually just initially thinking that maybe, like, I guess Python got so good that, you know, when it came with it, they realized that they need, maybe they standardize it and throughout the entire like Python world and library and community, that they need to have their own little Docker to represent it.
Yeah, I mean, yeah. So that would be my guess as well, is that in order to run Django, you need Python. And so like, why do a bunch of extra work? If someone already has a good Python image going and it's officially maintained, then it's like we're doing extra work for not much benefit. That would be my guess. But anyway, so the point is that you can search here for different things. If you want to use Postgres. So here we have an official Docker image for Postgres. And this is a bunch of different, so I think you probably have like version 15 something installed locally, but you can see all these different versions of Postgres that are available to you in different operating systems. And then the README will kind of describe how to do this. So this is a run command. We'll look at this in a second. But so the benefit is that I can, if I want to, I can run, you know, Postgres version 11. If I have specific requirements for my application, and on my local computer, I have, you know, Postgres 15 installed, but I need Postgres 11 for my application. I can just use Docker and say it's totally isolated from the rest of my computer. Okay, so that's Docker Hub. So that's where we would get this. So Python is the name of the kind of base image, and then there's a colon, and then the 2 is called a tag. So this would be some more specific version of this image, like Python 2, Python 3, Python 3.11 dash Alpine, whatever the case is. And then the next line, this is optional, but this workdir basically just it sets a default prefix. So it says create this directory structure inside of the image, and then from here on out, anytime I use like dot to reference the current directory, it will actually use this. So I'm creating an operating system with Python 2 installed, and I'm saying make their user source app, and then also this copy command. So this copy command will go from and to. So most Linux terminal commands will start with like from and to. So copy from to. So from here is the local file on my computer. And this is, so my computer is called the host machine, because it's hosting the Docker container. So on my machine, on the host machine, copy over this file that I've written into my container. And I'm saying dot here, and that dot is really user source app. So that's basically it. Like, this is what my program needs. I have to have a Linux machine with Python installed, Python 2 installed, and I have to copy over my code. That's basically it. So now I have a little operating system with my code installed on it. And this command will run when you actually run the image. So running the image is kind of like, either like, turning on the computer or executing a function. Executing a function is more like it. So this will run when you actually run it. So I have everything ready to go. I have the operating system, I have Python, I have my code, and then that's all just sitting there waiting. And then when I actually run it, it's going to say execute Python and then execute this file. So what I want to happen ultimately when someone runs this container is to execute this Python file that I've written. Are there any questions so far?
Can you access your container with the command line?
Yes. So there is, I guess I should have mentioned this, prerequisite for doing this is to have Docker desktop installed on your machine. I'm trying to think where that, yeah. So if you don't, you can just do that now. And if you're on a Mac, it's very straightforward, and I think even on a Windows machine. Is anyone using a Windows machine? Forget. Yeah. So it should be basically the same. So Docker Desktop does provide you with like a GUI interface, but nothing that I do is going to use that. We're just going to use the command line for everything. Okay. So once you have, let's say, this full description of your program, then you're going to actually want to build the image. And you do that with this Docker build command. So I'm going to first just execute Docker This might be easier if I use the terminal window. Hmm. All right. So I'm going to do ls so I can see that I'm in the same directory here. So what I'm going to do is Docker just by itself, and it's going to say what are you doing. But you can look at all the different commands that are available to you. You don't have to. There's really just a couple that you're going to use, so you don't need to worry about all this stuff. But the one that we're going to look at right now is called build. So build will build an image from a Docker file. So we have a Docker file, which is just like a description. It's just a description of what we want our operating system, and then we're actually going to build an image. So some of these terms are a little abstract, but an image would be, in images, it actually downloads everything you need and packages it up, so it's ready to go. So to do that, we're going to do Docker build, and then actually let me do that. Here. So Docker build, and then we need to give it a Docker file. And the Docker is pretty smart. So if you say the current directory, it will look in the current directory for a Docker file. And if it finds one, then it'll just use that one. You can also, be more specific, but you rarely need to do that. So Docker build dot look in the current directory, which has a Docker file, so it's going to automatically know that you mean this. Okay, so we have the basic build command, and we can. You can also specify lots of other flags. One of them is you can give it a name. So if you don't specify a name, it'll just assign it a random name. But if you give it a name, which -t for tag, so they use tag instead of name, but a tag, and I can say Python to container. And if I execute this, we're going to get a whole bunch of output on the screen here. So this is Docker downloading all of the stuff you need. It's downloading the operating system. So depending on what image you have, this might take more or less time. And Docker is also very aggressive about caching stuff. So the first time you run a command like this, it'll take a while, and then the second time it should take almost no time. So any questions while this is downloading?
Yeah, I have one. So you would be able to ignore a lot of these files, right? When you push it to GitHub, similar to npm packages.
Yeah, so that's a good question. So if you actually don't need to do anything with these files that are downloaded. So if I look here by ls, like my actual code isn't affected at all. So a Docker file is almost like the requirements.txt file that you would use in Python. It's just a description. So someone else on another machine will have to actually download all of the operating system stuff. So as long as the other computer has Docker installed, it should just be a pretty consistent process. So I know this is hard to read with the colors, but there are a few steps. So just, you don't really need to worry about the nitty gritty. It's just gonna, blast output at you. But you can see that one of three. So these are steps. And notice the first step is from Docker. And then you can see Python 2 here and blah, blah, blah. So this is actually the first line of our Docker file that it's executing. From blah, 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 Python 2. So it's downloading the operating system with, this particular image. It's actually another image. So just like, we have class inheritance. So Docker files work the same way. I have a Docker file that pulls this image, which pulls from another Docker file, which pulls another image. And so you can kind of chain those back. And then the second one is this workdir, which comes from right here. And then the third line right here, 3 of 3, is copying this. Notice that this line doesn't count, right? So it's just one, this is 3 of 3, the last one here. So this last line doesn't run when you build it. So we're just building the image. So now it's just like, it's all packaged up, but it's not actually doing anything. So everything's downloaded, packaged up, ready to go. But this only gets executed when we want to run it. So at this point, I have now downloaded this image. And so I should be able to look at them. So you can look at all the images that you have on your local host machine with the command docker images. And the more you do this, the more images you'll have. You can also, delete them. And so, cleaning up after yourself is part of the process. But so we gave it a name with a -t flag. So build -t Python 2 -container. So that's where this is coming from. Otherwise, it'll just do like a randomly generated name, which is fine. And then the tag is latest. So latest is the default tag if you don't provide one. So you can provide one. You don't need to really worry about that right now, but eventually you'll probably want to version your containers. So you can use tags to version things. And then this image ID, this is just, internal stuff which you can use to reference this container later. And it tells you how big it is and when it was created. So one important thing, which you don't really need to worry about, but I'm just going to mention, is that one of the big priorities when it comes to making containers is making them as small as possible, which is why if you go to Docker Hub, the first thing you see is, let's see, first thing you see is Alpine. So Alpine is a Linux distribution, which you don't really see very often. Like people don't just use Alpine at home, but it's a very minimal Docker image based on Alpine Linux. So it's only 5 meg. So it's a very, very small, minimal operating system. And so people often will start with Alpine and then build on top of it to keep their images small. Okay, so we've now got this thing. So let's say we want to actually run it. So to do that, you use the Docker run. So here we had Docker build and then a optional tag and then a third argument. So it's Docker, the command, and then the argument. So most Docker commands are going to follow that pattern. So Docker run, and then the argument. And the argument here is going to be the image or the name. I always forget, but I'm going to do this. So Docker run blah. So now we actually are basically going to create like a running instance of this container that we have. So we have our Docker file, which is a description. Then we have the image, which is like the actual, all the operating system stuff downloaded and ready to go. And then when we run it, we're actually going to execute it. So there's a whole bunch of additional arguments that you can pass it. There's a few common ones that you'll see. This -it is basically going to allow you to connect your terminal to the containers terminal. So has anyone ever done anything like SSH? Anyone heard of this?
I think I set something up for GitHub with that.
Yes, so GitHub does have, you can clone using SSH. Damon, there's some weird like looping audio thing going on your end, and I can't hear you talk. Okay, yeah, we can. You can try later. Jesus, are you familiar with? You're also muted.
Yeah, am I familiar with what?
SSH.
Yeah, I've used it with GitHub as well.
Okay. So can anyone tell me like in general what SSH is?
Isn't it
my-
like some sort to access something?
Yes, yeah. It allows you to access. So it basically allows you to access another computer. So I can have my terminal, and then I can remotely access another computer's terminal.
Sounds like hacker stuff.
Yeah, exactly. And since we're a hacker is a software engineer, basically, just a kind of software engineer. At the moment, I'm not. It's really strange. I'm not sure what's causing that. But yeah, so instead of having another actual computer somewhere else on the internet somewhere that you can remotely access, we're going to have another little computer kind of inside our computer that we can do the same thing to. So it's as though this image could be running anywhere in the world. It happens to be on our computer, but it really could be anywhere. So I'm going to use the -it flag, which will basically switch my terminal to my images terminal, and I'm going to run it with bash. So I'm going to run the image, and what I'm going to do is I just want to access the terminal. So this is just going to give me access to the terminal of this image that we've created. So I'm going to run this. And now you can see that my terminal prompt has changed because I'm not on my computer anymore. I'm inside this other computer. And notice that it starts with /user/source/app. That's because I basically said that's the working directory, which means that everything that I do kind of assumes that as a prefix. All right, so now I can do ls. So I'm in the Linux machine, and there is my Python file, and I can see the contents of it. And I can create a directory. dir. I can cd in the hi there. So I'm on a a Linux machine, and I can do anything I can do on this machine. So I'm gonna go back in here, and I'm just gonna execute. I'm gonna see what version of Python I'm using. So I'm using Python version 2.7. So even though, like, this, it's hard to keep track of this, but I'm not really on my computer anymore. I'm inside of a different computer that I've described using this Docker file. So now I can execute this file, Python py.py, and this actually executes. I can also, I forget the command. Yeah, you can see what operating system this is on, just so you are sure that it's not your computer. So this is Debian GNU Linux. So the code name is Buster. So you'll see Buster pretty frequently in Docker images, which just means Debian. Okay, so now I want to go back to my terminal. I want to go back to the terminal on the host machine. The host machine is my laptop, which is hosting this Docker container. So I just type exit, and now I'm back home in my terminal. And now I'm gonna just Docker images. I can see that image is still there, and I can do Docker PS, which I should have done earlier, but that's fine. So Docker PS will list out all of the running instances. So we don't have any running right now, but if I add another flag -a, this will give me all of them, whether they're currently running or not. And let me expand this. It's hard to read this output, but so here is my image that I created, and then when I ran this Docker run, this command right here, Docker run -it, my image name, and then bash, it created this. So all that stuff that I was doing, like running the Python file, LSing, and so on, it was happening in this instance, basically. So it tells you what image it's derived from, and then it gives you an arbitrary container ID, which it just makes up. And you can also control that, but that's fine. And then there's also a made up name, and it tells you, so this is the command that I ran with. So I'm gonna run another instance of the image. I'm gonna do the same thing. So Docker run. And now I'm just gonna exit. And if I do Docker PS-A again, I have another one. This is basically like this is an actual instance that ran of that image. Okay, so you can kind of see what's happening. Another thing that I can do is I will run this again. So I'm going to run it without the -a flag. So I don't have any currently running Docker images on my computer. So now I'm going to run it, and I'm going to open up a new tab here. And I'm going to do Docker PS. And this time I actually get output. So this is the running container. So I have another container that's running right here. So in this other terminal, it's running. So that's why I get the output. Okay, so I'm going to exit out of this. And now if I go back here and run Docker PS again, I get nothing. Okay, so let's say I want to clean up some of this stuff. So I can do docker ps-a, and now I want to get rid of these because I don't need them. So docker rm, just like remove, and then I can pass it the container ID. And it removes that. So if I run this list command ps-a, that one is gone. RM, and you actually can pass it you don't have to pass it the full container ID. You can just pass it a couple characters as long as it's enough for Docker to identify the container. So DA, so that also works. Docker RM 0A. So now if I run this again, so I've cleaned up everything after I'm done running it. Okay, so now what we'd like to do is to actually run the container. So originally we built this container for the purpose of running this Python command. We want to execute this file. So what we just did was we ran it and attached to the terminal and then messed around and then manually ran it. But we would like to just run this without having to go through all those other steps.
So when
Yes.
we're creating the instances of the container, would that be the proper terminology?
Yeah, so usually the instance is called a container. And then
Okay. So all those instances with the container IDs are all separate containers basically.
yes.
And that would be what you consider running it manually.
Well, so anytime you execute the run, you basically anytime you execute an image, you'll create a container. So some of the terminology is a little abstract, I guess, kind of annoying, but so there's kind of three levels. The top level is the description of what you want. And the next level is the build. So you build an image. And then to actually get something that happens in the real world, you run an image and that creates a container. And once you have a running container, it's just like another running computer somewhere. It happens to be on your machine, but it could be anywhere. It could be anywhere in the world, basically.
Is it you usually only have one container per project that contains like everything you need, or is there multiple containers that you would use?
That is a great question, and we will get into that. For now, we're just going to worry about one container, but eventually, yes, we will have the ultimate goal of this. What you will end up doing is you will have basically three containers. You'll have a Postgres container. You'll have an Nginx container, which is going to be your web server, and then you'll also have a Django container.
So essentially, like for each image, you want to have a separate container.
Yeah. So yeah, each image will end up being a separate container.
Okay, cool.
And then you don't need to worry about this now, but has anyone heard of Kubernetes before? So real, in like production grade applications, you're gonna have very complicated. You're gonna have lots of different containers and lots of copies of this. If you have a web server, you'll have 10 different copies of the same web server so that they can all handle different traffic. So there are ways of managing lots of containers. We're not gonna really worry about that right now.
I always see memes on the internet and how difficult they are to work with.
Yeah, they definitely can be, but it's even more difficult to do it without containers. So as every every new convenience or technology kind of solves some problems and ends up creating some other ones, but I think containerization is a pretty clear win across the board. Yeah, sorry, Devon. You could try. Did you quit and rejoin?
You
Still?
can type your question too.
Yeah. Okay. So let's go ahead and kind of run the image as we originally intended. So to do that, I'm going to do Docker images and then Docker run. We'll do that. And look at that. So it ran the container, it executed this command that we gave it, and then it was done. So if we do Docker PS, the container is not running right now. It did its job, right? It executed that file and then it was done. And then I can do Docker PS -A, and that's the container that actually ran. Okay, why don't we take a 10-minute break and then I'll show you a couple more things. But this is 90% of it. Okay, we'll come back. Share my screen again. All right, so we have created a Docker file which describes the container that we want. We pulled from a base image. We know that our application needs Python 2, so we found an appropriate base image, put that in the from, and then copied over the file in there. And then when we run it, we want this command to execute. So what I'm going to do now is do just a couple more, just show you a couple more commands. So there are a bunch of options that you can pass. So one of these is the -D flag. And before, when we ran it, it like immediately occupied the terminal. So if I run the image again, so we just go like our terminal is now taken up by this terminal. So if we don't want that, we want this to run in the background, you can just add a -D. And now that container is actually running in the background, but I can do whatever I want with my terminal now. So I can do Docker PS, and this container is running now. It's just running in the background, basically. So this is running in the background, and now let's say, okay, I don't want this to run anymore. You can stop the container, and you do Docker stop, and then you give it the container ID. So now if I do Docker PS, there's nothing running. I can also, if I want to run it using bash, so I'm kind of overriding the default command. So I'm going to run it again as a background process. And now I decide as it's running, I want to copy over another file into there. So I'm going to create another file right here. now I have another file right here in my current directory. So I can go something like this, and I can use the cp command. So just like on your Mac, you can copy files using cp. So I can do cp right. So now this showed up. So I copied this file, which is in the current directory, to this other file, which is also in the current directory. So just in the same way that you can, basically any Linux command is going to have an equivalent Docker version. So I'm going to delete this. And I'm going to do Docker. So I have a running container that's running in the background now. So Docker cp. And I'm going to do other. And I'm going to copy it. I'm going to copy it into this container. First, I'm going to get the container ID, which is actually right here, but I'll do Docker ps again. So here's the container ID. So Docker cp other, and I'm going to copy it into the container. And then you use a colon, and then you can specify the directory inside the container that you want. So here's that directory that we've been using as the default working directory. So I'm going to copy it into there. So colon, and then that. And I run that, and nothing happens apparently. But now I'm going to, I can actually go into that container that I have running in the background. And you can do that with another command, which is exec. So this is very similar to what we did here, except this works on a container that's already running. So you can exec, this is like SSHing into another remote computer. So Docker exec, and then I'm going to do the same thing. I want to access the terminal, and I want to do it for that particular container. So this is the made up name, but ours will be different. So now I'm going to go here. I have a running container, Docker ps. I can see that it's running. I copied a file into it, and now I want to check and make sure that that file is there. So Docker exec -it, and then I give it the container ID. It's right here. I could also use this name, but I'll use this. Bash. So now I'm inside the container. And if I do ls here, I see this other file that I copied there. And I can confirm that. I can do less other. I don't have less on this thing. So cat other. And it's hard to read, but that's the output from the file. All right, any questions? So that's pretty much it. Are there any questions about that? All right, so I'll go over the challenge for today. So the challenge for today is basically going to be getting familiar with Docker. So you have a bunch of little kind of mini tasks to complete. So you'll pull down the latest Alpine image, et cetera, et cetera, et cetera. So you'll have to look through documentation and look stuff up, but should be relatively straightforward. And then the ones at the end are going to be a little bit more complicated. but you should be able to look stuff up and figure it out. And if you have questions, you can post them in the Slack channel. So try to figure it out, of course. If you can't figure it out, post your question in the Slack channel, and then other people, including me, can try and answer them. And if you don't get the answer you're looking for that way, then you can just ask me or Tiffany directly. Questions?